Hey everyone, welcome back to another video. Today we're going to be talking about conditional statements. Let's get started. So let's read the definition of what a conditional is. A conditional is an if-then statement that relates a hypothesis, the part that follows the if, to a conclusion, the part that follows then. So what we're actually going to do right now is we're first going to write a conditional statement. The conditional statement is usually an if-then statement, where the part that follows if is what we call the hypothesis, and the part that follows then is what we call the conclusion. So here I have a normal statement saying my hair will be shorter if I cut it. So I'm going to rewrite this statement as if it was a conditional. The clue as to which of these, what part of this statement would be my hypothesis, is to look for the word if. So I'm going to go ahead and I'm going to change this a bit. And instead I'm going to say, if I cut my hair, if I cut my hair, comma, then we have our conclusion, then it will be shorter. So we've rewritten the statement so that it's a conditional. And here I can see that my hypothesis in this example would be if I cut my hair. A lot of times the way we describe the hypothesis too can be with the letter P. That's the way we denote it. We say if P, then our conclusion a lot of times is referenced as Q. A lot of times you'll see the words if P, then Q, or you'll see this diagram, which means the same thing. P, then Q. Okay? So, if I cut my hair, then it will be shorter. So this is an example of what a conditional is, how to write it. Again, this would be my conditional down here, if I cut my hair, where you can see the two parts to it, the hypothesis, which is in blue, and the conclusion, which is in green. The next part to conditionals is a lot of times we try to find what's their truth value. Are they true or are they false? And a lot of times we have this table to help us decide whether or not a conditional is true or false. We call it its truth value, and we use the truth table, which breaks it down into two parts, really, based on what's the hypothesis and what's the conclusion. Is the hypothesis true or false? And then is the conclusion true or false? And then based off which combination of those two we have, that'll determine whether or not the conditional in itself is true or false. So here we can see that if I have a true hypothesis and a true conclusion, then that'll lead me to a true conditional. All right? Now, if I have a true hypothesis but a false conclusion, then I have a false conditional. And this is actually the only case in which you will get a false conditional. If I have a true hypothesis and a false conclusion, that will lead me to a false conditional. Now, regardless of what the conclusion may be, if I have a false hypothesis to begin with, I will always end with a true conditional. Okay, and I'll give you an example of that later, and I'm going to give you an example of how we use this table to help us determine the truth value to our conditionals. Let's go ahead and let's look at one, and we'll determine its truth value. So here we have the conditional statement saying, if a pair of lines is parallel, then they do not intersect. So first, let's go ahead and see what is our hypothesis, what is our conclusion. Our hypothesis is this beginning segment. If a pair of lines is parallel. So this is our P. Then they do not intersect. That would be our Q. This is our Q statement in red. So let's say, okay, if our pair of lines are parallel, if this is true, let's say that's true. If we have a pair of lines that are parallel, we know that's true. Is our conclusion true based off our hypothesis? Well, let's see. Parallel lines mean that there are two lines that do not intersect. So because of the definition of parallel lines, we know that this conclusion has to be true about those lines, because it's the definition of parallel lines to not intersect. So here we have a hypothesis that's true, and based off that hypothesis, our conclusion would also be true because parallel lines do not intersect. So I would look in the table to see what do I get when I have a true hypothesis and a true conclusion. Well, if I have a true hypothesis and a true conclusion, then that would give my conditional a truth value. Okay? And that's an example of how we use the table. Let's go ahead and look at another example that will give us a different outcome. So here we have another conditional statement. It says if the product of two numbers is positive, then the numbers are both positive. So again, if the product of two number positives, here this is going to be our hypothesis P. Then the numbers are both positive, Q. So first let's analyze the hypothesis. The hypothesis would be true in this case. The product of two numbers is positive. Okay, so let's talk about how can I use two numbers to get a positive product. So that means when I multiply two numbers, their product is what I get when I multiply them. So I want two numbers, I want to multiply them together, and I want to get a positive number in the end. There's two ways I can actually do this. One way would be to have two positive numbers multiplied by each other. That'll give you a positive product. So 2 times 2 is 4. All those numbers are positive. But in math, we also know that two negatives multiplied by each other will also lead to a positive. So I could easily change this 2 into a negative 2 multiplied by a negative 2, and that'll equal 4. So based on my hypothesis, these are the ways that I can get two numbers and have a product that's positive. Now let's see if our conclusion actually goes with what our hypothesis was saying. So the conclusion states that then those numbers are both positive, which we can clearly see here that I can actually use two negative numbers. So this would lead me to a false conclusion. So my hypothesis is true, but my conclusion is false. If I go back to my table, if my hypothesis is true, but my conclusion is false, then my conditional statement has to be false. So that means that this statement has a truth value of false. So these are two examples of how we use a truth table to find the truth value of our conditional statements. One was true, one was false. Now, I missed the knee on that one. So I hope these examples have helped. Now, I didn't get into the examples of what would happen if my hypothesis was false. An example of having a false hypothesis would be that you start off with something that's not necessarily true. So for example, if I say something, if a square has 3 sides, I could go ahead and just label that entire conditional statement. In a way it seems odd, but we would actually label it true because the hypothesis was false to begin with. So it doesn't really matter what the conclusion is, okay? Or I could easily say another example is saying, if my real height in real life is around 5'8", if I were to start off a conditional about myself saying, if I'm 6'2", then I can dunk on a basketball court. Well, that would be a true statement because the hypothesis is false, so it doesn't really matter what the conclusion is. I can't base any truth value on starting off with a false hypothesis. It's just going to be a true statement regardless of whatever I conclude it with. So again, most of the time we don't focus on things that start off with false hypothesis in geometry. Most of the time we look at things that actually start off with a true hypothesis. I hope this short video on conditional statements has helped you out, and hopefully you understand how the hypothesis and the conclusion work and the if and then statements. And if you have any questions, feel free to leave those in the comments. I highly recommend the next video you watch be the one on inverse and contrapositives that also has to do with conditional statements. Thanks for watching.